welcome to Chemistry Fever. I'm Sandhya, I'm your chemistry educator, and today we are going to start IGCSE chemistry series for both core and extended, right? So we will cover all the topics of core and extended. In extended, as we know, there are certain extension for some topics, and there are some topics in extension which are not included in core, but I will explain you overall. So the topic relative to core will be helpful for the students who take core IGCSE chemistry, and the detailed version will be helpful for the one who go for extended syllabus for IGCSE chemistry, right? So here we are going to begin the first unit, that is particulate nature of matter. So friends, as we all know that we have 3 exams in IGCSE: MCQ paper, multiple choice paper, paper 1 and paper 2. Paper 2 is for extended and paper 1 is for core. Paper 4 and paper 3. Paper 3 for your core and paper 4 for extended. Paper 5 and 6 practical and alternative to practical, right? So there are some chapters which include information for all the 3 chapters, right? Like if we speak about state of matter, it contains information for MCQ as well as your structure paper, but hardly you will get any information for your ATP paper. Maybe a knowledge of this chapter can be helpful for solving some questions, maybe a part or 2 parts for ATP paper or alternative to practical paper. But basically this chapter contains more information about multiple choice questions and structure paper, that is paper 1, 2 and paper 3 and 4, right? So here we are going to start particulate nature of matter. So as I have told you, we have 3 papers, so we have to pay focus on each and every word, because for multiple choice questions every word is important. Question can be created from any word, any sentence. Sometimes we think that there are some pictures, yellow portion, green portion, blue portion, right? We think it is not containing in the syllabus maybe, but sometimes you may get questions connected to that, because those are the applications. Some information written below the picture, maybe it is the application of the topic that you are doing. So maybe if the question is being asked pertaining to some application, that it will be helpful. So here we will discuss everything in detail, along with add to your knowledge GK. Along with I will also give you some exam tips that this question can be asked in this manner, so that will help you to connect when you solve different assignments and your practice papers. So here we go. So this chapter is divided into 4 sections, right? So students, I'm going to write all 4 sections. So in the beginning, I'll give you a flow chart which will give you information what this chapter is all about. So our first part is solid, liquid, gas. This is the part 1 first for particulate nature of matter. Part 2 is kinetic theory of matter. Part 3 is change of state of matter. And the last part is diffusion. And diffusion is evidence for movement of particles. Right? So in this video we will discuss about the first part, solid, liquid and gas, and the forthcoming videos you can see the other topics of this chapter, particulate nature of matter. So this is a fundamental chapter for chemistry. If you go for any board, not for IGCSE, any board, the first chapter is the basic information about matter, right? So when we see matter, what do we think? What matter looks like? How it behaves, right? Look like means can you see it, or is invisible, or the size of the particle is so small that you cannot see, right? So when we see matter, some questions click to our mind. Maybe at some point of time we can see what is matter, right? At some point of time maybe it is microscopic, we are not able to see. So can we see all type of matter, right? So we have to study in this chapter that what is matter, how it looks like, how long you can see it, or what is the boundary, right? Suppose if there is a range of particles, and what is the range in which you can see? Can you see everything in the universe? Can you see air? No. We can see if there's a colorful gas. But that color will give us a hint that this particular area is composed of this particular gas. But if the gas is colorless, can we see? But it is matter. So we have to see those things, right? Next. Okay, students. Next thing is how it behaves. Now, what do we understand by behavior? If I see behavior, let's see about your behavior and my behavior. So what do we understand by behavior? Behavior means, first of all, behavior considered for me like, suppose if I'm angry, how I behave. If I'm happy, how I behave. If I'm sad, then how I behave. Or if you are coming to me, maybe you are my student, some of my friend, my parents, my colleagues, then how I behave with them, right? It means how is my interaction with others. That is also behavior, and right? And second thing is, if some conditions changes in my life, right? Suppose I'm angry, I said I'm happy. So it means I'm getting my favorite dish. Suppose I have to do something that I really don't like, then how I behave. It means behavior with respect to certain set of conditions and behavior when I interact with someone else, right? So it can be my family member or it can be some outsider. So that is behavior, right? So if we speak about universe, in universe we have a lot of particles around us, right? So if we speak about matter, it includes all substances and materials which is making up your universe. It means if we speak about universe, there is nothing which we can say that it is not matter, right? So considering all these factors, we have 3 states of matter. 3. Nowadays, now some students will think, ma'am doesn't know. There are 5 states of matter. Yeah, we have. But the other 2 states of matter in IGCSE we don't have for now. In IB or in other boards, maybe you will study when you go for higher studies and higher detail of the particular topic. So for 9th and 10th IGCSE or year 3 or year 4, we have only solid, liquid and gas. But still, while studying solid, liquid or gas, I'll give you a short account of what are the other 2 states of matter. So for now, we have 3 states of matter: solid, liquid or gas, right? Apart from solid, liquid, gas, there are 2 other states, that is plasma and Bose-Einstein condensate, right? So let's begin with the first topic, solid, liquid or gas. Solid, liquid, gas. Okay, so let's start with solids. So as everybody knows, what are solids? I am a solid, liquid, gas, a combination of all. This board is solid, liquid or gas. Okay, let's start with us, human beings. We are made up of 5 states of matter. So do you know what are those 5 states? Think for a second. Yeah. So we are made up of 5 states of matter. The 5 states are earth, soil, fire, sky and water. So it means we are a combination of all these. Yeah, if we select a particular part like bone is made up of calcium, phosphorus. Bones are solid, okay? But our body is made up of 5 states of matter, right? If we go further, let's speak about the board. This is solid. How can we say it's solid? If I'm drinking cold drink, it is liquid for me, right? How can I say it's liquid? Okay, next, gas. So particularly in this topic, though I know that if we discuss about solid, liquid and gases, we have countless points in our mind and we can classify them or differentiate their properties based on many parameters. So we will also do the same for this chapter, but particularly for this topic, topic 1, we have only the broader classification. It means the main differentiation, main differences between solid, liquid and gas. Then in the further topics like kinetic theory and other change of state, we will discuss the other properties which are responsible for certain type of behavior, right? So now, Solids. So if I say about solid, the first thing that comes to our mind is, if I'm speaking about the board. Board is a shape. If you can say it's rectangular, right? Or maybe a square. If I play with a ball, it is spherical. It is solid, it is spherical. So it means if we speak about solid, solids are those substances which have a definite shape or a definite volume, right? Solids are those substances which have a definite shape or a definite volume. It means a particular shape which gives that, okay, this is a solid, and a defined volume. In terms of maths, we know that. How can we define, like suppose if solid is sphere, then how can we determine the volume if solid is rectangle? Let's not go into mathematics, but we know, right? How it means we have certain characteristic formula and we know the different measures. How can we determine the volume of a particular solid? Okay, now we have some solids which have a particular characteristic shape, like sugar. If we speak about glucose, its shape is cuboid, right? If we speak about NaCl, if we see the structure of NaCl, its shape is also cubical. Though if we take a small grain, we can say no, it's not cubical, but the size is so small. If you see the microscopic structure, it is cubical, right? Okay, so I'll make for you. It's not required to memorize that structure, but just for the understanding purpose, I will make it for you. So don't be scared with the structure. You don't have to make it or you don't have to learn it. You just have to understand that if we say solid, certain solids have a specific shape. So if I say this is your Cl and this dark dot is your sodium, and if I place the positions, this is one NaCl crystal, right? And if we take 1 spoon of NaCl, it's contain millions, you cannot count. If I give you a work that you have to count all the NaCl crystals in 1 spoon, let's not talk about spoon. If I say 1 pinch, is it easy to count? No. So these are chlorine particles, ions or particles, and these are also chlorine, and this is sodium. So this is NaCl, right? It has this shape, though if we take this in hand, we will not be able to see it, right? So it has a particular shape. So my question is, because as I have written that solids have a definite shape and a definite volume, right? So if I go to the next point, do all solids have a particular characteristic shape? No. So we have two types of solids: crystalline, those who have a particular shape, like copper sulfate. If you see, they are form crystals, and crystals have a particular shape. If we take like more salt, or we say K-manophore, they have a particular fixed shape, right? Geometrical shape. But if we talk about other type of solids, those do not have, they are solids but do not have a particular characteristic shape. So that is like wax, right? Plastic, glass, it means you can change. Sugar, if you take a very small crystal or a very big crystal, the proper shape is cuboid. You cannot change it. Even if you crush them into powder, the small particle is cuboid. But in case of glass, plastic, we can change it as we want. Right? So solids have a particular shape and a particular volume, but not all solids. Some solids are crystalline, it means they have a definite shape, and some are amorphous, they do not have a definite shape. If we want, we can change their shape providing certain set of conditions. Okay, next thing, if we say solid, liquid, gas. Okay, so now as we are talking about solid, so is it solid all the time? Suppose I have a solid in my hand. If I say this is solid at room temperature, right? So there are some questions in IGCSE when you see some papers, past year papers, or maybe some assignments given by your school. So they will give you some table kind of questions. Okay, in that table they will give you some melting points, boiling points, and some range of boiling point, melting points. Based on that you have to predict it's solid, liquid, gas, ionic compound, covalent compound. So that we will take up later, because ionic covalent we are not doing now. So it means if we are saying a particular substance is solid, it means we are saying that it is solid at this particular temperature. Suppose I am standing today, this is room temperature. Room temperature is say 25 degree. So it is 25 degrees C at which a particular substance is solid. Maybe if I decrease the temperature to a certain value, the state may change. Now the question is, how can you change the state? By decreasing temperature for a solid. What more can you do? Solid is means you cannot further compress it, right? So that we will take up now after 2 minutes. So solid means there is a movement of particles. Movement in the sense, when we say solid, there is a vibration of particles at their mean position. So if we further cool it down, suppose I cool a solid to -90, -70, -200, that vibration will also get stopped. It means now all reactivity ceases to 0. So if you decrease the temperature of a solid or of a gas, cool it down to -270, it will become the fifth state of matter, Bose-Einstein condensate. So that is just the hint, so we don't have to go in detail for the fifth state. So I hope I have made you clear, because even in solid we say, though they are stable, but still particles vibrate. If you stop that vibration by cooling it to sub-zero, that vibration is even stopped. So now no reactivity. That state is Bose-Einstein condensate. Okay, leave it apart. So solid, it means there are sometimes they ask a question, what type of arrangement solid has? It has a regular arrangement, right? So now if we speak about solids, we are saying if we increase or decrease temperature, what will happen? Suppose I have iron block in my hand. If I heat it to 2000 degrees Celsius, it will turn into liquid, right? It means if we are saying it's solid, it is at a particular temperature. If I have water in my hand, if I heat it to 100 degrees, still can it remain water? No, it will turn into gas. It means the particular state of matter is depending upon temperature. So if we increase temperature, the state may change. If we decrease temperature, it again may change. Similarly, we have pressure. If we increase or decrease pressure, then still the state may change. So solids are those substances which have a definite shape and a definite volume, right? Now solids slightly, I'm saying slightly, expand on increasing temperature or slightly contract on decreasing temperature. Because we know solid is fixed. Before you get its melting point, solid, it's not like solid if changing or solid if expanding, it means it is becoming liquid. It can slightly expand, slightly. That's why if we see the glass windows, the bottom side sometimes slightly thickens up because it flows down when there is high temperature, right? Similarly, if we see the railway tracks, they slightly expand when there is very high temperature. You will not notice it. It's at molecular level. So temperature is very high, otherwise they will buckle up, they will bend down. That will cause serious accidents. So they will slightly expand at molecular level, right? So they slightly expand on increasing temperature and slightly contract on decreasing temperature. So this is expansion and contraction for solids. Third, Solids are not compressible. You cannot compress them. Suppose I press this. Can I compress this? Can I compress? Now a question that comes to students' mind most of the times, if we sit on a mattress, it is compressed. So it is solid, liquid or gas? It's a solid. But when we see mattress, there are small pores in it. That pores contain air. So if you sit on the sofa or a bed, it means that air is compressed, not the solid. So solids cannot be compressed, right? So with all this information, the solids are over. Now we will switch to liquids. So if you want, you can note it up. So now students, we will go to liquids. The next state of matter, liquids. So I will not rub it. So you want, if you can, but you have to note the full information again, but I will just change few words that will work for me. So now if I say liquids, so do liquids have a particular shape or volume? Yes, they have a particular volume but not a particular shape. Then they acquire the shape of container. If you keep them in a round ball, you can see, okay, the liquid is looking round or circular. If you keep them in a square container, you will feel the liquid is acquiring the shape of container. So if there is the container, suppose this is the container, if you fill liquid up to here, then this shape will give you the shape of the liquid. So it does not have its own shape, it gets the shape of the container. So liquids are those substances which do not have, or let me write it again, which have a particular volume but do not have a particular shape. They acquire the shape of container. They acquire the shape of container. Right? So this is about liquids. Wherever you keep it, they will get the shape of the container. Now next is again temperature dependence. If we say solid, a solid is solid at room temperature because its melting point is below or above. So below or above. So what do we think? Melting point is above room temperature. So it will not melt at room temperature. That's why it is solid. So if we speak about liquid, liquid also expands. Liquid expands on increasing temperature. Liquid expands on increasing temperature, but if you really make the temperature so high, is it cross boiling points, and it will start turning into gas. Otherwise it will also expand. The molecules slightly go far away. How the molecule behaves when you increase temperature, that we will see later in the other part of the chapter, in other videos. For this video, just understand that liquid expands. It will also expand, though it's not turning into vapor, but still molecules are slightly going away from each other. Right? The volume will slightly increase. The volume will increase. It means it is expanding. Maybe 20 to 20.2, right? So contraction not possible. Contraction will be means molecules coming closer, slightly decreasing volume. Okay, so they will expand slightly more or increasing temperature. Next is compressibility. Liquids are compressible. But again, it depends upon container. Suppose you have taken liquid in a metallic container. The metal you cannot, if you can slightly, suppose the water you have kept in a wooden container, right? So wood is very thick. So if you try to compress, the wood cannot be compressed. Suppose you have taken a plastic bottle and then you have kept water in it or cold drink in it. If you want to press, you can press. But if you keep some solid in the bottle, let's take a very simple example. How can we say that they compress? Okay. Suppose you have a syringe. Okay, this is a syringe. Suppose I put some chalk powder in it. And next is, suppose I put some water in it. So this is the chalk powder. So if I want to compress, can I compress the plunger of the syringe? No, because it is solid. Solids cannot be compressed. So if I take liquid, so if this is the liquid, if I want to compress, yes, I can compress. So liquid molecules can be compressed. Solids cannot be compressed. But the compressibility of liquid is lesser than that of gas. Next is gases. So gases full of energy, particles far from each other. If you leave gas in this one corner, suppose not speak about particular gas, let's speak about something nice. Suppose I put perfume in the corner of one room, okay, then what will happen? You can feel the fragrance throughout the room. Or suppose you open the door, you can feel the fragrance even outside, right? It means the gas particles, they can move far because the molecules have least force of attraction between them and they occupy the whole space available to them. If you enclose them in a cylinder, it will occupy the full cylindrical space. If you leave the gas in a room, it will occupy the full room, right? So gases, they neither have they neither have a fixed shape nor have a fixed volume. So it means it will occupy the whole space available to it in a particular prescribed space. So it occupies the full space of a container. Or space provided to it. Next is gases expand everywhere. The expansion of gas is maximum if you increase temperature, because already the particles are full of energy. As compared to solid liquid, gas particles have large amount of energy, right? So if you increase the temperature, they expand to a larger volume, right? So gas expands to a larger extent. So gases expand to a larger extent if we increase temperature. And similarly, compressibility of gas is maximum. As I give you example for cushion or for sofa, when we sit, it is the gas which is compressed, because the small pores in the mattress, they contain gas. So wherever there is gas, you can compress it. So I gave you example of two syringe. In one syringe I kept chalk powder, in another syringe I kept water. Maybe in the other syringe there is nothing, only air, faster. Suppose this is the syringe, right? And there is nothing in it. You can quickly push it down. So compressibility is fastest, right? Because air particles have a lot of space. So suppose this is the solid. The particles are very close. So how long you can compress it? Slightly, depending upon the distance between them. So they can be compressed to a very smaller extent, otherwise they cannot be compressed. So in ideal conditions we say they can never be compressed. So if I take liquid, so this is the particle, this is the particle, still there is space. So if you want, depending upon your container, you can compress. But if we say gas, so one particle here, here, lot of space, so lot of compressibility, right? So what we have studied in this topic, that what is matter, behavior, if you increase temperature, what is solid, what is liquid, what is gas. Our universe is made up of matter. Solid, liquid, gas are the three states of matter, the fundamental states of matter. What is the basic difference between solid, liquid, gas? Based on the shape, volume, expansion, compressibility, depending upon temperature. So with this, topic 1 ends. If you have any question, you can just send me a mail, or you can also write in a comment if you have any question related to this topic. For the next topic, kinetic theory of matter, please watch the second video. Till then, have a good day. Bye-bye. Wonderful time. See you soon in the next video. And all the best for all your upcoming exams.